2C1, which is graphing quadratic functions in standard form. So we know what it looks like now. We've been working with standard form a little bit up until today, and now we're going to figure out how do we specifically graph in this form. So we have the properties of this graph before we actually get to the graphing, which, if you notice, has the same A that we've had since even when we started absolute value. We had an A in it that told us the same information about stretch and shrink and reflection. But the three forms specifically also told us that. Remember, vertex form has, and you don't have to write this, but this is the vertex form, just as a quick recap. That was vertex form. We started with that form, and it had the same A. The only difference is we had H and K that told us about the vertex, whereas now we have this like B and C that we're going to work with. And then we just a couple of days ago got to intercept form, which was y equals A, same A, but then it was x minus p, x minus q, and it told us our x-intercepts. So that was like the key features of each one. The first one gave me vertex. The second one gave me x-intercepts. Now let's see what we get, what's so special about this form and what information it will give me. But again, the beginning part is all very much the same, where it tells us, remember, the graph opens up if A is positive or if A is greater than 0. I'll write positive in parentheses there. And it opens down if A is less than 0 or obviously negative. And then the same things as before. It's a stretch when the number, your A value, if you ignore the negative sign if there happens to be one, or it's the same thing as saying take the absolute value of A and ask yourself, is it a number bigger than 1? If it is, greater than 1 would mean it's a stretch, which means the graph will get narrower or skinnier. And then if it's a shrink, it's going to be wider. The graph would be wider, and your absolute value of A would be less than 1. Or we kind of think of it as also A is between 0 and 1. All right, the axis of symmetry now, we do need to memorize an equation for it. Just like we had an axis of symmetry equation to help us find it in intercept form, it was the one that was P plus Q divided by 2 when you had to get halfway between the intercepts. Here is the equation for AOS for standard form. And you have to memorize this. It goes negative B divided by 2A. Okay, so that right there is something we use a lot in this unit. We're going to keep using it kind of for the next few weeks. Anytime we're talking about the AOS for standard form, or specifically even vertex for standard form, because we need this. It's the x value of your vertex. So that says the vertex has the x coordinate, negative b over 2a as well. So it's your AOS. It's also the x value of the vertex. You need to eventually find the y value of the vertex so you can plot it, which we'll get to in just a couple minutes. And then finally, there is one more piece of info. If you look at your equation, you have 3 letters, A, B, and C. The A and the B we used right here for this equation. We didn't use C yet. And so C is actually your y-intercept. So that's the nice thing. Whenever all those questions on the last few homeworks were asking for y-intercept, if we just knew it in standard form, we would just be able to look at that number, C, whatever that last number would be, that doesn't have a variable attached to it, and that would be my y-intercept. So the point 0, C is always on the parabola. And that'll help us graph, because that'll be one of the points that we get when we are graphing. So let's go ahead and now practice the steps that we're going to take. I'll write them down first, and then we'll jump into our first graph. So it says determine whether the parabola opens up or down. This is kind of like an optional first step, because some of you will probably still realize what it is doing, up or down. You don't have to physically write it down that it's, okay, it's going to open up. But remember, we have to look at your A value. If it's positive, it's up. If it's negative, it's down. So you'll decide that first, because it kind of helps to see what's the graph going to look like. And then make sure at the end, when you're done, it makes like a good way to check your work to know that you did it right. The next step would be to use that equation we just talked about, x equals negative b over 2a. To help you find and draw the AOS axis symmetry right onto your graph. Then we have to plot. Okay, so next we are going to find and plot the vertex, because you got the x value for your vertex, but you did not get your y yet. So you would take the answer you end up getting for your x, and you'd plug it back in, substitute it into the x's, and find your y, just like we did for intercept form. It was really no different. And then finally, we'd have 1 point so far on our graph, which is not much. We'd have a point and the AOS drawn. We would need one more point, which is the y-intercept. And remember, the y-intercept is 0, C. So you take the last number of the equation, the number that does not have x's attached to it, that's your c, and you would put it into the, as an ordered pair, 0, comma c, and plot it on your graph. Finally, you would reflect the y-intercept that you just plotted over the axis symmetry. So if it's, we call it a matching point. It's where you take the point that you have for your y-intercept and you figure out how far away is it to the line of symmetry, and then you go that same distance away. So we'll practice doing that. We were doing this already when we were in vertex form, or even, well, we didn't do it intercept, but you were doing it in vertex form already. And then finally, drawing a curve through the plotted points. Okay, so let's go ahead and try our first example. First thing we always start with is like labeling our A, B, and C. It makes it a little bit easier to keep track of the numbers, but A, B, and C are just numbers. They are not variables. So it's just -1, 6, and a -8. Notice I did not put any variables, no x's, no x squareds, anywhere in that box. So then I'm going to decide which way it opens, and since there's a negative in front, that's opening down. And anytime a graph opens down, we have a maximum. Okay, so when we have opening down graphs, that means we'll have the highest point we'll look for when we're done to help us see what the maximum is. So here's, we did our one step first. We already figured out which way it's opening. We're now ready to find our AOS. So here is the formula one more time. X equals, I'll write it up here as well, -b over 2a. Here's a hint. Put parentheses around the whole denominator. If you don't do that on a graphing calculator or a scientific calculator when you are solving and you're trying to do it all in one step, the calculator will give you an incorrect answer because of how you're typing it in. So you have to either put parentheses around the whole bottom or do it in 2 steps. So here's what doing it in 2 steps would look like. You would do -6, because remember b is 6. I'm doing -b divided by, I'm going to put parentheses around the bottom just to show you what this would be, but it's 2 times -1. And usually when I put a negative, I usually put parentheses around that as well. So I kind of have like 2 sets of parentheses here. This is how you would type it, the whole thing into a calculator. Right? So let me show you that. But you don't always have to just type the whole thing in. You can do it in multiple steps. So -6 divided by parentheses and then 2 times. You don't need parentheses around the -1 on a graphing calculator or any kind of calculator, as long as we're telling the whole denominator to be in its own calculator or in its own parentheses. That comes out to a +3. Okay, or you could do it by hand and say, okay, -6 divided by -2 is 3. That's fine too. You don't have to show all your steps, but that's kind of the setup. Now that we have our x value, we just need the y value to help me come up with my vertex. So far it's 3 comma something. So I have to find my vertex by going to y equals, back from the original equation here, take this 3 and substitute it in for each of those x's. So y equals -3 squared plus 6 times 3 minus 8. We can type this whole thing right into the equation, or right into the graphing calculator or calculator, and see what you get. So negative, and then a parentheses after it, 3 squared plus 6 times 3 minus 8. And that comes out to 1. So equals 1. That's your y value of your vertex. So you can write that ordered pair, 3 comma 1. So let's go ahead and plot that point. And let's draw in the AOS as well. So remember, always draw your AOSs in. Some of you are not doing it on homeworks, and you want to make sure you're continuing to do it on every homework, every quiz, every test, or you will lose half points. All right, so 3, 1 is this point for the vertex. So far I have 1 point. We're getting close. We only need 3 points to be able to graph a parabola, as long as it's not like the first 2 points. This is why on vertex form we don't just leave it the first 2 points next to it, because it looks more like a V then. So I can also fill in this. It is a 1 for the max, and then we'll go ahead and finish graphing the rest of this. The next thing you do is you figure out what's your y-intercept. So notice that C number, that -8, that's your y-intercept. So I'm going to write 0 comma -8. The nice thing is you don't have to do any work with this. It's just that last number. So we'll come over to here on the y-axis, count down to 8. There's my y-intercept, 0, -8. and final point that we need would reflect this point over. So let's count till we get to the the axis of symmetry. 1, 2, 3 units to touch it. So then 3 more units to the right would give me that final point, which I don't even have to label. It is sitting at like 6, -8, but it doesn't have to be labeled. I'm going to go ahead and just draw in my parabola now. So I know it's better to have 5 points on a parabola, but with standard form equations, you can just have 3 for the vertex, the y-intercept, and then 1 reflected point. All right. So we're just going to answer some questions here about this graph now that we're done with it, but that's how we would walk through graphing a standard form equation, and we'll practice more on the next page. So the domain is still all real numbers or negative to positive infinity. Please make sure you're picking one way to write it, not both. And then for the range, you're going to say everything below 1. So either y is less than or equal to 1, or if you're using the other way, negative infinity to 1 with the bracket. That's the interval notation. And then end behavior is still the same. Since both arrows are pointing down, we have as x goes to negative infinity, y is going to negative infinity, and as x goes to positive infinity, y still goes, oops, sorry, that's a negative infinity. Okay, so it's negative, negative, because those arrows are both pointing down. The last 2 questions, and we've been practicing these kind of on homework and even last few days specifically. Well, now that we're figuring out each of the forms, it's practicing how to get it in each of the forms, because eventually you want to be flexible enough to go from one form to another and get all the pieces from each form. So the vertex form, all you need for it is the vertex and the same a value of your equation. So you're going to start it with y equals same a value, which is just a negative. You can call it a -1 if you want, but it's just a negative there. Parentheses around the x minus h squared, and then a plus k. So the hk is this 3, 1 that we found, right? That's my vertex. So this would be x minus 3 squared, whole thing squared, plus 1. You can also look at your graph and see, does that make sense that I'm moving right 3 and up 1? Because that's what the translation would be based on my h and k. Now, intercept form, remember we start it kind of the same way. Let's start with y equals and the negative still there. But this time, intercept form is going to have 2 sets of parentheses. So we need to fill this out, and usually the part that's easy to know is the x's that are there. But then there's either like a plus or a minus each time with the actual x-intercepts. Well, when I go back to this graph, I actually can see where the x-intercepts would go. It would be at these first 2 points that are right next to the vertex, like going to the right and to the left. And the reason for that is because of what the a value is. Since the a value is -1, it's almost like, I know it's not a slope, but you're treating it almost like that, where you go down 1 and right 1 and down 1 and left 1 to get those 2 points. Now again, you don't always have to label those 2 points, because on standard form, we're just looking for the vertex and the y-intercept and reflecting it. All right, so now that we know what those x-intercepts are, let's go ahead. I'm going to write them here. This is sitting at 4, 0. The first one was at 2, 0. So I just have to switch those numbers when I write them into my equation. X minus 2, x minus 4, and I'm done with intercept form. Right? All right, so example 2 here. When I start to do this, I can still fill in my a, b, and c, 1/3, but then b is 0, because there is no middle term there. It's not c is 0, because the x is always the one that has the middle term with it, and there's no x here, no middle term. C is -4, right? So if I was to try to figure some of these details out, I would say, okay, it opens up because it's positive a value. It's got to have a minimum, and then I would go to do my AOS. Here's my problem. As soon as I start my AOS, my formula or my equation is -b/2a. Well, first of all, -0 is the same as 0. But anything that I put in the denominator here, even though there's a fraction there, is still going to give me 0. All right, so this is still going to give me 0 for the x value. That means when I get my vertex, I'll have to substitute 0 back in to find my y value. But what we're going to see here, though, is that the vertex and the y-intercept are going to be the exact same point. So technically, this equation here, you could treat it as a vertex form problem or a standard form problem. And some of you might prefer one versus the other because vertex form sometimes seems like a quicker way to maybe graph. Standard form is probably just that if you had all the same details, but in this case they're the same. So let me just show you here what it looks like when I substitute 0 in for my x. It's going to come out to -4. So 0, -4 is my vertex, but so is my y-intercept, because remember, y-intercept is the c value, 0, -4. Or you can say when x is 0. So if I only have 1 point so far when I come to my graph, 0, -4, and my AOS is right here on this same line, x equals 0. I know it's hard to see when it's on the y-axis, but do your best there. I have to figure out 2 more points, or at least 1 point that I can reflect over, but with vertex form we always do 2 points that we can reflect because we don't want it to look like a V, right? So I'm going to kind of treat it like vertex form, where I'm going to just substitute in a number. Now you can choose what number to substitute in for x here. You can choose like 1, but if I do that, I'm going to probably end up with a decimal. So it would be easier to substitute multiples of 3. So if I wanted to substitute in a 3, for example, you could see that it would not come out to a decimal that way. So it's up to you guys what you decide to substitute in, but just show your work, please, for the substitution. So like doing 1/3, let's do 1 squared minus 4. You'll see the decimal that it comes out to. So if you need the calculator, it'd be 1 divided by 3 times, you don't really have to do the 1 squared because that doesn't really do much, but typing that whole thing in comes out to this repeating decimal. It's -3 2/3 essentially, but you can just round it, 3.7, right? Just as we're going to graph this, we're going to go to 1 and -3.7. So here is, let's see, down right there. So not the best point that we have here, and then you would go to the left of it as well to reflect that point. Instead, what would be better is to use the a value almost like a slope, where I could go up 1 and right 3, and up 1 and left 3. But again, try to make it so that your graph is more of a U shape and not a V shape. So like this. Oops. Okay, and we have our AOS. You can see how wide the graph is. But you could have also just substituted more numbers in for x. I didn't have to do 1. I could have done 1, 2, 3. I don't care what number we substitute in, but show your setup for that. Now generally these ones though, it would be more so treated as vertex form instead of standard form in that case. And then let's just fill out the details here. Min would be -4 because that's the lowest point it goes to. Domain is all real numbers, or negative to positive infinity. The range would be either y is greater than or equal to, -4, or -4 with the bracket and then to infinity. And finally, the end behavior, as x goes to -infinity, y is going up, so it's positive. As x goes to positive infinity, y goes up again to positive. All right, so on to this next example. Start with identifying your A, B, and C, because it helps to make sure you're plugging numbers in correctly. So A is 1, B is -2, C is -1. Using my equation, (b/2a), again, this time my B is already negative. So you can either switch it immediately before putting it into the equation, or do something like this where I wrote it twice, like a negative and a negative, even though that means positive. And then 2 times 1 would be my denominator there, 2a. It's always a 2 in the denominator. That's part of the equation. So this comes out to a +2 over a +2, which is equal to 1. So x equals 1. I'm going to go ahead and draw it in right away so that we have our AOS immediately. Let's find our y value for the vertex by substituting in a 1 everywhere you see an x. So again, it's plugging this 1 in here and here. So 2 times 1 minus 1. This comes out to a -2. And you can use a calculator for that. So the final vertex here to plot is 1, -2. So come over to your graph, plot that vertex. All right, the next point is always your y-intercept when you're working with standard form, which is the c value, -1. So the y-intercept is just 0, -1. Oops, I went too high. There we go. And then reflect that point. Now again, this graph is not a V-shape. Generally, we were doing 5 points whenever we got the first point, but with standard form, you just need to have 3 points. So it's okay if you just put those two and then just make it kind of appear to be more of a U rather than a V. It's not a V because it's not absolute value. All right, and then we just again fill out all the details. Negative to positive infinity, or all real numbers for the domain. Y is greater than or equal to -2, or you can write it as -2 to infinity with bracket first, then parentheses to go up forever. And finally, end behavior, as x goes to -infinity, y is going up to positive, and as x goes to positive infinity, y goes up again to positive infinity. And then we have the equation in vertex form. Remember, here is my vertex. So it would be y equals, there's no a value there, so it's just a 1, which you don't have to write in yourself. You can just call it, or let's go right to the parentheses here, x minus 1 squared, because that tells me to go right 1, and then down 2 would be a -2. And that would be vertex form. Now this one, you can't quite see the x-intercepts, so we're not going to put it in x-intercept or in intercept form because we don't know what they are. And so a quick summary here at the bottom just kind of reiterates that C is the y-intercept. It says, like, how are the values of A, B, and C in the equation related to the graph? We saw already that A tells you how the graph opens, up or down. It also will tell you how stretched out or narrow it is, right? So we can also say stretch or shrink, right? All things that we've seen before with the A values. Now the B value is actually going to kind of tell you, it's related to the the AOS, because if you guys know, you saw the -b over 2a, that was to help us find our AOS. So depending on what those values are, it's going to move your graph left or right to get to your AOS. So although it's not an H value, like the H that tells you left or right, it is telling you that direction. All right, so once everyone is good here, let's go to the back page and we'll just quickly talk about that last, we have a story problem and kind of like a model that we work with for the story problem, and there's 2 examples that we'll look at. So last page here at the top talks about this thing called the vertical motion model. We've actually talked a little bit about this. This is when we talked about dropping an object. When you drop an object from anywhere, you always have an initial height, and so the equation we used, which you don't have to write this down, but this was what it was. It was h sub 0, or h equals -16t squared plus h sub 0, where h sub 0, this like h with the 0 next to it, was the initial height of how you're dropping this object. And then the -16 was because of gravity, all right? So t represented time and how long it took until the object hit the ground. You could figure that out if h was 0. Well, it's the same idea here, except now we're not just dropping an object, we could throw an object, kind of like how you guys were looking at equations of doing that anyways. Now, here's what this one would look. It says an object's height, h in feet above the ground, after t seconds can be modeled by the function h equals -16t squared, plus, this is the new part, has this v with a little 0 next to it. This is called v sub 0. And it represents the speed or the initial velocity that the object is going with a little t next to it. So v sub 0 t plus h with the same 0 next to it, h sub 0. So that h sub 0 is the same as what we looked at before, which tells you the initial height. But imagine I'm trying to throw a football, or I'm trying to throw some kind of ball or object. I can use this equation because the initial velocity I could measure. There's like instruments that are tools that you can use to measure the initial velocity that when you like throw an object, or if it's like an airplane or some other object, or even an insect, for example, when as soon as they're jumping up or something, you can record or figure out what is that initial velocity, and then you use this equation to help you figure out when they would potentially hit the ground. It does say the model assumes the force of air resistance on the object is negligible. That just means if it's like a super windy day or something, those there can be factors, of course, that slightly make this different. But let's go ahead and try an example here with, it says Eric is competing in a track meet. He throws a shot put with an initial vertical velocity of 40 feet per second. So again, he's throwing this shot put, and it's going to form this parabola going up and then coming back down. And so we'll figure out, it says he is 6.5 feet tall. When his arm is extended, he can reach 7.5 feet. Now this 6.5 feet is extra information. It doesn't matter how tall he is. I just need to know the initial height of where he's throwing the shot put from. So that's my h sub 0. Whereas the v sub 0 was 40. So we're going to go ahead and substitute those numbers in, and then we have to figure out what's the maximum height of the shot put. Kind of think back to our first page of the notes for a quick second. Maximum is where you find the y value of your vertex. That's how we found the max value. Okay, so that's what we're doing here. To find the maximum, we're going to find the y value of the vertex. So let's go ahead and substitute them in, find out what the equation is, and then try to find that max. So negative 16t squared plus 40t plus 7.5. Okay, so we're not graphing it or anything. We are just coming up with the maximum. So to do that, we have to use the equation for the AOS. I'm going to say t equals here, even though we said x equals on the front page, because these are t's now. It's the negative b over 2a. So we'd have negative 40 over 2 times negative 16. All right, and using a calculator, that comes out to 1.25. So that means that 1.25 seconds later, after he throws his shot put, it reaches the highest point it's going to go. And then it starts coming back down, and then you could figure out when it comes back down, but we're not going to do that right now. We're just figuring out what is that maximum value. So we're plugging in this 1.25 in for each of your t's. So negative 16, 1.25 squared, plus 40, 1.25, plus 7.5. That comes out to 32.5. And you would put feet for the final answer there, because that's how long, or that's the highest point that that shot put goes before it starts coming back down. All right, and then we have one more we're going to finish up with. So the last one, it's the same idea with like maximums or minimums, but this time it gives us an equation to work with rather than using the model. So it says using that equation, that it says the profits of Mr. Unlucky's company can be represented by this equation, where y is the amount of profit that he's earning in hundreds of thousands of dollars, and x is the number of years that he's operating for. He realizes his company is on the downturn and wishes to sell before he ends up in debt. So he's trying to figure out when he got to the maximum profit and what was it. So it says, when will Unlucky's business show the maximum profit? So to do this, you're using the same AOS equation, negative b over 2a. So it's negative 18 over 2 times negative 3. Using a calculator, if you want to type that entire thing in, you can, or do it in pieces like this. Comes out to 3. 3 represents the number of years. So it will take 3 years for his company to have a maximum profit. So if he wants to stick with it for 3 more years, he'll get to the max. And if he wants to sell it right then before he starts losing money, that would be smart, right? Then it says, well, what is that actual maximum profit? So we have to take 3 and substitute it in to the equation everywhere you see an x. So that's y equals negative 3, 3 squared, plus 18 times 3, minus 4. And just use your calculator. You can just type the whole thing in. Negative 3, 3 squared, plus 18 times 3, minus 4. Comes out to 23. Now it's not $23, because that would be nothing. Let's go back up here where it said it's in hundreds of thousands. So you have to add that many zeros. 100 has 2 zeros. 1,000 has 3 zeros. So that's not bad. He is actually making that much money in dollars for the profit, which is good. 2,300,000. Yeah. And then it says, at what time will it be too late to sell his business? Then you're trying to figure out when it starts going into the negatives. So you could technically substitute in 0 in for the y, and then try to see where you would kind of lose money there. We're not going to do this one right now. We'll kind of come back to that. So this is where we will stop.